Hi everyone, let's provide the complete solution to this problem here. This looks a bit impossible, but we can solve it. Yes, what we are going to do is to square both sides of the equation, right? So I'm going to square what we have here, and we have this, then we have 1 squared. But remember that 1 squared is still 1. It won't change anything there. X to the power of 2 is x squared. Then this can take this out, so we multiply this by x, which is equal to 1 to the power of 3. Okay, 1 to the power of 2. Now, if you multiply these two, you're having x to the power of 3, and it's equal to 1 to the power of 2. But now, 1 to the power of 2 is the same thing as 1 to the power of 3. So let's still write this as x to the power of 3 being equal to 1 to the power of 3, since these two are the same. Now we're having two terms raised to the power of 3. Bring this to the left, so we have x to the power of 3 minus 1 to the power of 3 equals 0. Now the question commands that we solve this into detail. So we're going to get 3 solutions from here. The first thing is that we have x. Okay, let me give you the identity before we work this. Now let's say we have a cube minus b cube. This is called difference of two cubes, and this is equal to a minus b into a squared plus ab plus b squared. This is an identity in mathematics. Now the second step is that we put in the value x and 1 into this problem, into this identity. A minus b becomes x minus 1. Then here a squared is x squared plus ab, that is x times 1, and is equal to x, plus b squared, that is going to be 1 squared, and 1 squared is still 1, so we equate to 0. Now we apply 0 product rule. It's either x minus 1 is 0 or x squared plus x plus 1 is equal to 0. Now x is equal to 0 plus 1, and our x is just equal to 1. This is our first solution, and it's the only real solution, right? But since the question says we should solve completely, let's look at this quadratic equation. X squared plus x plus 1 equals 0. By the way, I said quadratic. Do you think everybody knows that this is a quadratic equation? Okay, for the sake of those that may not know, this is quadratic because of the square we have here and the equal sign, right? It is also quadratic because of the x. Now, let's go. We're going to use the formula for it, and the formula is x equals minus b plus or minus b squared minus 4ac under the root, then divided by 2a. So the next thing is for you to identify your ABC. Let me do that here. From here, our A is 1, our B is 1, and our C is also 1. Wow. ABC, everything is equal to 1. So let's continue. We're going to put all of them into this. A is the coefficient of x squared, B is the coefficient of x, C is a constant, so everything is 1. So x will now be minus 1 plus or minus 1 squared is coming here, minus 4 times 1 times 1. So we divide by 2 times 1. If we take a step, then our x will be minus 1 plus or minus square root of 1 minus 4, because 4 times 1 times 1 is 4. Everything is over 2 times 1, which is equal to 2. Now let us continue. Okay, so now x is equal to minus 1 plus or minus 1 minus 4 is minus 3, and this is over 2. Now, do you know that this is the same thing as plus or minus square root of 3 times minus 1? Okay, let me put this bracket. Everything over 2, right? So these and these are the same. Now, let's take a step. X will now be minus 1 plus or minus square root of negative 1 is I. Now, this 3 is not a perfect square, so let it remain under the root, and it's over 2. So from here, we have a 2-in-1 solution. So let's bring the 3 solutions together. Before now, we got x to be what? 1. And from here, we have 2 more solutions. So x is equal to, from here, look at this plus or minus. That means 1 is going to be plus and the other minus. So we have minus 1 plus I square root of 3 over what? Over 2. Then we have x again to be minus 1. Oh, we have minus now, right? This is plus, so this is minus. Minus I square root of 3 over 2. So we can call this our x1, x2, and x3. So these are the 3 solutions that will be obtained, or that can be obtained from the given equation. Thank you for watching. Please subscribe, like, and comment, and let me know how you feel about my videos.